Welcome back. We're in lesson 8. We're going to talk about something that we haven't mentioned before, and that's the names of expressions. So if we have an expression, it could be a single term like this. It could be something like this. It could be even more. It could be something like this. All of these are expressions. These are also something called polynomials, and poly just means many. When we have one, we could call it a monomial, or we could call it a polynomial. We could call it all polynomials and be correct. But you can also be specific and you could call it a monomial because it's one, mono meaning one. This could be called a binomial because there's two and bi means two. This could be a trinomial because there are three terms and tri means three. But nomial is a word that it's a suffix that we use to indicate a number of terms. That's all it means. So if you hear binomial, monomial, trinomial, polynomial, you'll understand what you're hearing someone talk about. That's all that's good for. You're going to hear us talk about polynomial equations. And all that means is you've got one or more terms with an equal sign on either side. So not an equal sign on either side, terms on either side of the equal sign. So you might have 4x plus, or 4 plus 2x equals 7 minus 3x. That could be the polynomial equation. You've got a binomial on each side, but you have that equal sign in the middle. Because you have more than one term here, it's going to be a polynomial equation. So that's all that we are saying when we say that big fancy long word, nomial, with a prefix. Now, there is something called the degree of a polynomial equation, and the degree of the polynomial is the highest degree term of the expression. So if we had a square here, a 2 on this x, the degree of this polynomial equation would be 2. If we had a 4 over here on this x, then the degree of the polynomial equation would be 4. And if we had a 7, we would say that this polynomial equation has a 7th degree to it. So you just look for the highest exponent, and that's the degree of the polynomial equation. Or just a polynomial, that would be a 7th degree polynomial right there. Just the highest exponent, that's all you're looking for. That's pretty straightforward and easy to understand. So let's move on and talk about some, let me spell polynomial for you so you get it right when you see it. Polynomial, just like it sounds. Then you have binomial. You're going to want to write this down so when you see it you'll know what I'm saying. Then you have trinomial. That's when you have three terms in the expression. And then a monomial, mono meaning one, and that's just a single term in an expression. So those are some words. This is many. This is 2, this is 3, this is 1. So you can write those down pretty quickly before we move on to graphing linear equations. Pause if you need to. I'm going to clear the page. All right, in graphing linear equations, when we first started learning how to do this, we learned how to make a table. Here's example 8.1. And I'll remind you about the table. Let's say we had a linear equation. We know it's a linear equation because you have an x and a y, and it is a trinomial. You've got three expressions, right? Or three terms in the polynomial equation that makes it a trinomial. So we know, I'm sorry, that's 3y. We know that when we have a equation of the line that we need to solve for y first. So that's what we're going to do. We're going to change sides and change signs. So we're going to have 3y equals negative 2x plus 6. Now we're going to divide everything because we have to solve for y all by itself. So we're going to have y equals negative 2 over 3x plus 6 divided by 3 is 2. So this is our equation of the line. This is what we're going to use to find our points on the line. Now, back when we first learned how to do this, we're going to review this right quick. We made a table. And what we would do is we'd say x and y. And for our very first point, we would choose the y-intercept. So we know that x would be 0. And the base is always whatever this number is here. And in this case, the y is a 2. We don't even have to do the math, right? Because we know if we put x in right here, that whatever it's multiplying against is going to be 0. So y is going to skip over this and equal this. This will be eliminated. So 0, 2 is our y-intercept. So then we would pick some numbers, and I always said to pick multiples of the x value in the slope, and we know that this is the slope. This is the format y equals mx plus b. B is our constant, x is our x value, y is our y value, and m is the slope of the line. So we look at the slope of the line, and I always say pick a multiple of this. So for x, so we'd pick 3, and then we'd pick 6, and then we would do the math. So if we subbed in 3 for x here, we would cancel the 3 out and the 3 out. We'd have negative 2 over 1. So we would have negative 2 plus 2, so that would be 0, would be our y value. Okay, so if we substituted in 6, we would have negative 2 times 6 would be negative 12. That would be 4, would be a negative 4 plus 2, so 6 would be negative 2. All right, so you can see how that works. You can also do it mathematically by saying, taking your y value, because y, your slope of the line is y over x, so you can take your y value and apply it to the number on top. 2 minus 2 is 0. 0 minus 2 is negative 2. 0 plus, you do your x value the same way. 0 plus 3 is 3, plus 3 is 6. So it works out, it follows the slope of the line. And then we would take these points and we would put them on our chart and we would graph. Okay, here's 0, 2. That's the first point. And then we would take our next point, which would be 2, 3. That'd be 0 or 3, 0. We'd graph that one, and then we'd come up with 1, 2, 3. That's 6, and 1, 2, negative 2 would be right here. And we'd graph that and label it. And then we would draw ourselves a cute little line from our points. Or we would try to. And then that would be the way you draw the line. Right? You find your points and then you draw your line through the points. And if you've actually drawn your grid with proportional markings, it would line up, but apparently I have not. So that's okay. That's the way we used to do it back before we understood slope of the line. That's back when we would use substitution of an x value in this formula to calculate y. All right, in 8.2, we're going to see how we used the slope method to graph the same line. So let me clear this. Pause if you need to. Sorry, I didn't have my pen on. I had my shape on. Same problem. Actually, you know what? I'm going to, let me clear this. I'm going to get some graph paper right quick because I think that's going to do better. There we go. Here's just some graph paper. All right, 8.2. And we're going to do the same line equation. All right, so we're going to solve it again just like we did before, and we end up with 3y equals negative 2x plus 6. Divide everything by 3. That gives us y equals negative 2/3 x plus 2. Okay. All right, that pretty clearly tells us where to start. So let's give ourselves a little graph here. There's one line. There's the other line. That's why I love this software, because it will straighten my lines out for me if I know how to line them up from the end to the beginning. All right, so we're going to graph this based on the slope method, and the slope method uses this slope here. And again, y equals mxb is your format that you want for the slope of the line. B is your constant, m is your slope. M is represented by y over x as a fraction. So in this case, our slope is negative 2/3. So that means that this negative means that whenever we graph a line from point to point, it's going to go down 2 spaces because it's negative. If it were positive, it would go up 2 spaces. And the x always moves to the right, no matter what. So it's going to go to the right 3 spaces, okay? So we're going to start by looking for our y-intercept point, and that is the base. X is always 0, and this is always the y, because if you put 0 in for the x, whatever this is times 0 is 0, and 0 plus 2 means y equals 2. So we're going to plot our point at 0 and 2, right here. Okay? And we're going to use the slope of the line down 2 spaces and over 3 in order to draw our line, or to plot our line. So down 2 and over 3. 1, 2, 1, 2, 3. All right? And that is at point 3 and 0. Okay? It's 3 on the x-axis and 0 on the y-axis. Now we're going to go down and over 3 again. 1, 2, 1, 2, 3. And this is at 6 on the x-axis and negative 2 on the y-axis. And we're going to draw our line just like this. I think I can get it to straighten up on this one. It should, because it's proportioned because of my grid paper. Very good. So now I have a straight line. And if you look, these are the exact same points we got before. We just used the slope of the line to figure out where those points are. Okay? And then there is the third way, and that's when we use the mathematical way. So if we were to take our first y-intercept, we just write it down. Here's our y-intercept. That's the first one we did. And we just look at the slope of the line and we do it mathematically. We don't even have to have a graph. We can pretend it's not there. If we take our y, let's do 3 points, right? We make our little lines there. This is the x. This is the y side. So let's take the x side. The x is a positive 3. Okay, so 0 plus 3 is 3. 3 plus 3 is 6. Negative 2, so we're going to apply negative 2 to the y side. 2 minus 2 is 0. 0 minus 2 is negative 2. Aren't those the same points we just got? Absolutely, because we use the slope mathematically and visually to find the points for this line equation, or equation of the line, sorry. So that's completely doable. You can either do it by making a table, or you could do it by graphing it, or you can do it by just mathematically adding from your y-intercept or subtracting, as the case may be. Just remember that what's on top is the y and what's on the bottom is the x. X is always positive, and then the y tells you whether or not you go up or down based on whether or not it's positive or negative. Okay, let's move on to 8.3. We're going to graph a different line. I'm going to clear the page. So 8.3, I can make that do right. And our line is y equals negative 3x minus 3. And here is our graph. Okay, straighten that out. Let me get another line going this way. Boom, straighten that out. All right, we're going to graph this just by looking at this. It's really easy. So this is a negative 3. That means we find negative 3 on the y-axis. 1, 2, 3. That's our first point. Our first point is 0 and negative 3. X is always 0 when we select this as our y. Okay? And this is the x-axis. This is the y-axis. So x is at the 0, and we come straight down on the y to find the negative 3. Now we're going to use our slope to find the next point. We have a negative 3. It's a whole number. How do we turn a whole number into a fraction? We put it over 1, and that's how we find our x value. So negative 3 for our y value and positive 1 for our x value. So we're going to come down negative 3, 1, 2, 3, and over 1. And it's always to the right for x. We're going to do the same thing again. 1, 2, 3, and over 1. Okay, and then we're going to draw our line. There we go. There's our line. And we can mathematically determine these points just by doing our quick mental math here. So x has a value of 1, positive 1, so this is going to be 1, and this is going to be 2. And negative 3 becomes a negative 6, which becomes a negative 9, because we added negative 3 each time. And if you look at the graph, this is 1, this is 2, this is 3, this is negative 3, this is negative 6, and this is negative 9. So we have graphed this correctly using both methods. All right. Now the only other thing that I want to show you is how to go backwards. And the way to, let's say you don't have any more space and you need to graph another point because that's the requirements of the problem. It says to graph 4 points. Well, you're running out of space. You can back up and go the other direction, and all you have to do is flip the signs. So instead of going to the right, you'll go to the left on the bottom. So you go over 1, and then if it's a negative 3, you switch it to a positive 3, and you go up 3. 1, 2, 3. So now you have another point. So you just back up from what you were doing before, and then you can add some more points to your line. You just do it in the reverse. And I'm going to stretch that out a little bit. Here we go. Awesome. But that's how you would add another point in the other direction. You just flip your signs and go backwards. All right, let's see. Do we have another practice problem? We do not. That is all we have for lesson 8. I will see you in lesson 9.